to my support material in the chat, because when I was publishing the I was trying to publish it on the website, and I think I broke something. Not everything is rendering properly. I'll fix that later, but you should be able to see everything from here. Okay. So, so basically, the topic of today is basically getting started with AI agents, right? So my goal for today was not really to show you like an off-the-shelf framework regarding agents. It was basically to, I mean, for me to make some research to understand exactly what people are referring to when they mention agents, and also how are agents put together, because it seems that for everything related to LLM, it's as if the things that are trending are changing very, very fast. At the beginning, it was all about prompt engineering, and then very quickly it became like custom GPTs, and then it was RAG, and then it was function calling, and then so on and so on. And the current trend is all about agents, because people realize that not everyone, at least on the technical side, will be part of a company that has enough funds to train an LLM from scratch, right? So one thing that's perfectly doable for and accessible to most people and most teams that are technical is agents. And that's one of the reasons why we keep hearing about agents left and right, but we don't know what agents are. So over the last couple of weeks, and mostly during this week, I've done some research, and I've read some articles, I watched a lot of videos, I even read some books to try to get a better sense of what AI agents are. Does anybody want to take a guess? And like, if I would ask you in the audience, if you have any idea what an agent are, what an agent is, an AI agent. Anyone want to take a shot at it? Yes, you can just speak. Go ahead.
Yeah, so good afternoon, everyone. Good afternoon, Ben.
Yep.
So if I want to define what an agent is from the normal parlance of the name agent is something that acts on behalf of something, right? So if you want to see what is an AI agent, it would be something that delivers a service on behalf of something else, say a server, so to speak.
So okay,
it allows you to connect to the service of the master.
Okay, so what you're saying is that an agent is something like a server that can perform an action on behalf of the user. Is that, am I understanding it right?
We can say that in that context as well.
Yeah.
You can do something on behalf of a user. Yes.
Okay.
Delivers a service or interaction on behalf of a user or a caller.
Okay. So with that same idea, what makes it, what will make an agent an AI agent, in your opinion?
So what will make an agent an AI agent?
Right.
If it is able to deliver intelligent service, of course, and the service has to be autonomous, so to speak. It's able to act with less
lesser interactions, so to speak.
Well, so this answer might be tricky because, for example, if you have ever worked at like, let's say like a bank, for example, usually at night after hours, they have some automated service that run to crunch some numbers, right? And it's very hands off. So in that sense, can we say that those background jobs are like AI agents?
Well, I would say no, but you can tell me if I'm wrong. I would say no, mostly because in those jobs you tell it and you give it instructions on how to do the job, right? So for example, like a batch job, you'll tell it, hey, pull this file, crunch these numbers based on this file, and then output it here, right? You're giving it detailed instructions to do it. Whereas my guess, AI agent is more, you don't necessarily tell it how to do it. It finds a way based on being intelligent, right? Finds a way to do it without you explicitly telling it how to do it. Total guess.
Okay. Okay. So, okay. Anyone else? You can just speak. Go ahead.
I would say that from my own understanding, the best way to describe what an AI agent is when you think about tech support. Let's say you hire somebody, you train them on your stack and all that stuff, and then they are able to use their intellect to understand and reason and also provide support that the other end user is looking for. So with that being said, an agent is some kind of intellect that you can train to actually execute some predefined actions without actually providing it the actions that they need to execute. So for example, you would just train them on how to respond to a user, and then you don't tell them, okay, based on the input, this is what you need to say, and then they will be able to use like the general intelligence that they have, and then provide some outputs that is useful to the end user.
Okay. Yeah, Kofi, go ahead.
Hi. So, in my view, AI agents, you can think of it as, for example, as we work on a project, we have the project managers, and then the project manager, under the project manager, you could have an HR analyst, a payroll processor, and maybe a technical writer. So what happens is the manager is the agent. He doesn't do the actual work himself or herself. The manager will basically ask his resources, which we can, in this term, the HR analyst, payroll processor, we can think of that as tools. So the manager will determine who can best work on a certain task. So once the task is allocated to these tools, the tools goes out and execute on the actions that, for example, an HR analyst knows what it's supposed to do for its job, right? So the HR analyst tool will go out and execute those instructions and provide feedback to the manager. And, you can loop through that process.
Okay. So from all of your answers, I think everyone can kind of tell that the actual notion of agents is very nebulous, right? And that was my struggle for the last couple of weeks, especially this week, to the point that I haven't even slept last night. I was still trying to figure out some stuff. So, so before we get to the actual definition, I want to bring to your attention some concepts that I kept seeing over and over again while I was researching the topic. Right. So the first concept that I kept seeing like the most is this one, React. It doesn't refer to the JavaScript framework, as you can see. It's actually a paper written by, I'm gonna open the PDF and show you. I forgot the name of the authors, but basically it's a concept that basically tries to describe the combination of those two things, like a reasoning step and then an acting step, meaning that whether it's in the context of agents, right? The agent might receive some input, and then for it to perform the action, it first needs to think about it before acting. So in that sense, this concept that's related to agents in a way tries to mimic human behavior. Because if you think about it, try to think or come up with any scenario in your personal, I mean, at the personal level, right? Let's say you want to grab a cup of coffee. Well, would you be able to go ahead and grab the cup of coffee without thinking about it first? If you do that thought experiment, you'll notice that it's pretty much impossible for us humans. In anything we want to do, we have to think about it before taking an action. You know, even when it's a reflex movement, you know, like you're trying to avoid like a bug flying into your eye. You know, there's still some sort of processing that happens before you make the move to avoid the bug coming for your eye, right? So in that sense, this React concept, when applied to agents, tries to mimic human behavior, right? You can read the paper. Hold on, let me copy the link here. I'll paste it in here. It's published on Archive. So let's reopen this. I mean, I'm not gonna read it, but it's essentially that's what they are trying to describe in here, and they show some examples of like how they prompt like an LLM, and then the difference that it makes in the quality of results, right? So it's an interesting document. You can definitely go over it and then get a clearer idea about what React is. So reason plus act. So another concept that I saw coming over and over again is the concept of self-refine. So this idea is very interesting. So one example that I can use is, for example, let's say you go to ChatGPT. I don't think ChatGPT does it out of the box, but it's just for illustration. Imagine that you go to ChatGPT. Quite often when using ChatGPT, we type a prompt, we get an answer, and it's not usually the exact answer we are looking for. Or maybe the answer might be slightly wrong, or there might be like cases of hallucinations. And then what do? We send some successive prompts to basically tell ChatGPT that, hey, this is wrong, you hallucinated here, revise your answer. And then based on that additional prompt, ChatGPT will revisit its answers and make adjustments, right? So in a way, these additional prompts that we write are forcing ChatGPT to revise itself, basically make some refinements. So the idea here is that there is a way to basically prompt an LLM in a way that it automatically corrects itself. So there's this idea of a loop, that will, as part of the loop, collect the initial results, inspect it, and then make a decision about the quality of those results, if they are good enough to return to the user, or if they require some additional revisions. Right. So this is what this concept of self-revise is about. There are also some GitHub repos are associated with it. So let me share this in the chat. On window. So again, this is another paper which is published on arXiv, so you can definitely read it. And this is the diagram that kind of like illustrates what I was trying to say, right? So the input comes in. There is some sort of processing. You can see that this is like a brain. So maybe it stands for, it's basically a model. So in the example that I gave, this will be ChatGPT. So ChatGPT, it's as if ChatGPT will get its results, its initial results, and then go through a feedback step. And that feedback step will decide whether the result was good enough, and then it should be passed along to the user, or if it should refine it, and there's like a loop that keeps on going until the feedback loop provides a good enough score for returning the answer to the user. Right. Any questions so far? Okay. So
I have a question.
yes, go ahead.
So when you say the loop, it loop until it gets I would say the good answer.
Mhm.
How does it know when it reach the right level?
Yeah. So okay. So a good example that I saw, I think even just last night, I was watching one of those AI conferences. I think I posted the link to the conference on Discord. So there was one presentation where basically the way that the presenter like coded the interaction with the LLM was that whenever there's an answer that comes back, it's asking the LLM again how it will rate that answer. Like assign it a 0 score or 1. So 1 will mean that the answer is relevant to the question being asked, and then a 0 will mean that it's not relevant. So whenever the extra step will provide a score of 0, it will basically prompt again. I don't know if it answers your question. It's basically some custom code that people write. So you have one piece of code that sends the initial prompt to the LLM. When the response comes back, there is another prompt that goes out to the LLM again, and then this prompt basically asks the LLM itself how it will rate that answer based on the question. You know, so it really depends on the task at hand.
So the LLM will be capable, because I know it's a machine,
Yeah,
to rate itself his own answer, basically.
pretty much, yes.
Can you have it send the answer to multiple LLMs besides itself, like maybe Claude and Gemini, and hugging other LLMs to see how it rates it to get a consensus?
Yeah, it's possible to do that. It's basically just code, you know, so you can code it any way you would like. So you could do combinations like you're sending the initial prompt to, let's say, ChatGPT, and then have Anthropic Claude provide feedback on the answer, and then have Gemini do something else with it again. Like you can implement it any way you want. Those are just ideas, you know, for things to that those are just ideas that those researchers that publish those papers, you know, are bringing, right? They made the research to show that using these approaches, it's possible to get much better answers, right? But then as far as the implementation is concerned, whoever is coding it has the freedom to be creative, right?
You can also use humans for the feedback side of things, right?
Definitely,
Yeah,
there is something called human in the loop. That's
right.
exactly that.
Okay. Yeah, I was gonna say because like the humans, I think, to me, provide the better feedback.
Yes,
I mean, than the actual like a robot or a model, right? So okay.
yes, definitely. Yeah. Any other question regarding that?
So no one can really tell us what success looks like. We have to define what that looks like for our application.
Yes, I think it's custom to the domain and the task at hand, right? So for example, the example that I mentioned, if I remember what the presenter was doing, he had a set of articles that he inserted into a vector database to do some RAG task, you know, retrieval augmented generation, and he will ask a question, and then his agents had the freedom to look up the answer inside that vector database, or do a search, like a Google search, for example, right, to come up with the answer. And then whichever path the agent decided to, whichever data source the agent decided to use, it will ask it. He had a step to basically ask that. I mean, he had an extra step to basically rate that initial answer based on how relevant it is, you know, to the original question. You know, so, and he kept it simple, like 0 or 1. You know, but it's easy to imagine that we could have a different scoring system, like 0 to 5 or something like that, depending on the needs. Yeah.
Interesting. So yeah, the KPIs can be difficult. The key performance indicators can be difficult to determine depending on the complexity of the task. It seems like a whole new meeting just about evaluating would be worthwhile.
Yeah.
And I think depending on the domain, you can build that success. You can have a success, probably a database or something that the LLM can also reference as part of the context. So it depends on how the developer builds the app.
Mm-hmm. Yep. So, okay, so let's continue. Where was I? So we just saw self-refine, and the last concept that a related concept that I kept seeing, it's basically under like flow engineering. So by flow engineering, what I understood from that is that it's pretty much like a workflow or a DAG, a DAG standing for directed acyclic graph. Actually, let me share it with you. It's also a paper on archive. Let me see. Actually, let me go to the GitHub. They had an interesting graph. Let me share this one too. Yeah, so on this one, like this paper, like dealt with this thing called alpha codium. I think it's probably some research related to coding assistance. And again, you can read it on your own time, but basically this is how the processing is done. You know, so you can see that it's a workflow that on the left side like follows a very specific step, right? And then again, we see that idea of an iteration, right? You can notice that the arrows, you know, potentially might loop, you know, on specific steps, right? So in a way, it has some ideas of what we just saw related to self-refine, like built into it, right? So it will navigate like this, and then it might loop here or not, and then go to the next step. It might loop here again or not, and then to the next step, and then it might loop here or not. Then eventually, it will yield the final solution, right? So basically, the main idea here for flow engineering is that based on the problem that you are trying to solve, there might be a specific flow to come up with the answer, like a procedure, right? And if you think about it, it's similar to how us humans are also solving problems. You know, there's a way to solve problems the very hard way by doing a lot of unnecessary steps. And then eventually, when the problem domain is better known, we come up with a specific process that can efficiently address the problem, right? So in here, by looking at the graph, I can take a guess that whoever came up with this workflow, basically after trial and error, discovered that this is the best way to solve this particular problem, right? Any question on that? Okay, so let's proceed. Okay, let me see here. Okay, so like I was saying, there are a lot of agent frameworks out there, right? And from our discussion earlier, by trying to guess what an agent is, or sharing thoughts about what agents are, you can see that the concept is very nebulous, right? And not only that, this whole field of AI right now, like I was saying, it follows trends, right? So when I see things like this, I'm not saying that frameworks are bad. They are most likely good enough for some purposes, but I'm a bit skeptical because the whole thing is so new and so fast moving that I have some concerns about any framework trying to place itself as the way to basically do meaningful work in that field, right? So I'm not saying that those are bad; those are worth exploring, but I think that there's also a need to understand what's happening behind the scenes, right? Otherwise, we risk like constraining ourselves to how the framework author thinks about this problem domain.
Right. The general purpose engines may end up adding more capabilities that could make these frameworks irrelevant.
Right. Right. Exactly.
Yeah, and just to add to that, at the same time, the framework builders, the long chain and the crew AIs, they are also on a continuous development. Initially, LangChain has the LangChain agents. Recently, they have the LangGraph
Right.
as the direction, as the next level of creating agents. And I think this week they've launched LangGraph Studio or some form, a new application where they're looking for beta testers. So as Ben was saying initially, this area is moving very fast. So something that you learn today may not be used in the next month or two.
Yep. Yep. And also, again, I'm not picking on this framework in particular, but I forgot where I saw it. I can see it right now. But if I'm not mistaken, like some of these frameworks even have like, I mean, well, basically the way that open source is done like nowadays, it's at times it's hard to tell apart like what's actually open source all the time and what business related. You know, sometimes like the lines are a bit blurry. You know, so there's also this risk of like being caught up into a business, you know, and basically we don't want to be prisoner of any open source project, especially if it's tied to business, right? We want to instead understand, have a better understanding, and then have the freedom to write code by ourselves as much as possible. Okay. So yeah, so those are some examples. Like the most popular ones that I saw were basically Crow AI and LangChain. I actually started taking a course on deep learning that AI for Crow AI, but the very first example, I couldn't get it to run properly. I basically copied the code exactly as in the example, prompted it to do some work, but the agent never actually completed. It just kept running and running and running and running, and then eventually it errored out. I have no idea why or how. Yeah. Anyway, so what if we want to build our own agent? Like, what do we need in order to build an agent, right? So one thing I've noticed by taking a peek at, for example, Crew AI and some other agent frameworks, I've noticed that they either use LangChain behind the scenes, or they use another library called Instructor. So let me share the link on Instructor. So for those who have been coming to this meetup, they have probably seen Instructor before. We used it as part of demos for a handful of presentations. So the main idea behind Instructor is that, let me see here if I have an example. Okay, so let's take this example here. The main idea behind it is that when we prompt an LLM, usually if we just get plain text back, it's very difficult to work with it as part of code, right? In code, it's much better to write logic and functions and all that when we know the shape of the data, right? So Instructor, in simple terms, it's a way to, has a way to, allows us to prompt an LLM and then get structured data back, right? Internally, it has a way to coerce the LLM to return us data in the shape that we are looking for, right? And yeah, yes, go ahead.
Yeah. So I guess maybe you just answered my question. When you say we get structured data back, I think most LLM returns when you hit the API, you get back mostly JSON, right? Which theoretically is a structured format. So by using Instructor, you're saying that we can set it to the format that we want back. Basically, is that how you say it? Like we can
Yes.
customize basically the return payload.
Yes.
Okay.
Yes. Yes. So, for example, actually, I have some code examples here I can show you. Let me see if I can run this one. Okay, I think that's the one. Let me open VS Code real quick. VS Code. Okay, so let's close this. Close that. Okay, so let's pick this one. I'm using Marimo. It's oh, sorry about that. Let me grab the link for you. I'm using Marimo for notebook. I just started using it this week. I just thought it was an interesting it's an interesting tool. Let me share it with you here. So now,
quick question. Can you just create a prompt to tell it the format you want the output to be, the structure of the format?
yes, that's what I want to show you. Let's see. Let's start. Okay. I think it's coming up. Let me close this one. Okay, so it's up and running, but why is it not showing up? Let me do it again. I think weird. Yeah, what's happening? It's wait, I think I broke something here. Let's see. And let me do it from the terminal. Yes. So let's try to- Okay. Actually, okay, I think it's open. Why is it sorry about that, guys. I think I messed up something. Give me 1 second. Let me shut this one down. Oh, okay. I think I know what I did. Sorry. Okay, so this wishbone. Okay, I think this is the one. Okay. Okay, so let me copy this URL back to Chrome. Okay. So do you prefer the dark mode, or I can switch to light mode? Which one? Light mode?
Light mode, yeah.
Let-
And maybe increase the font just a little bit because it's a little small.
Okay.
So
Is it
that
better?
is, yeah, it's better. Is this local? So Marimo is a local thing. It's not a.
Yes, it's just like Jupyter notebooks, but I'm just
Mm,
running it locally. It's just a web server.
okay.
Then it gives you this UI for editing Python. Right?
Okay.
So okay. So in here, I'm just importing some libraries. Like I said, I'm using the instructor library, and on the side we have like different features. I think, yeah, if I select this, we're gonna have some live documentation. So after importing these, I'll make sure that my OpenAI key is loaded, and then since it's basically part of instructor is to also be is to also provide a common API across LLM providers, right? So in my example here, like I'm gonna use just GPT-4 Omni, but you know it's easy to wrap like Llama 3, Claude, etc., right? And then I have some helper functions here to set up an LLM client using instructor. And once I have this, I can instantiate them. And then like in the instructor example that we saw, I create a class called user details. And behind the user details extends Pydantic. Pydantic is basically a library for Python that adds more features on top of on top of Python typing, right? So this structure here, what it says is that the user details are made up of the username and its age, right? So in here I have a simple prompt. Again, I'm using GPT 3.5, which is the client configured over here. Or is it? Yeah, it's configured over here, 3.5 Turbo. And what it says is that you can see that this part is similar to the way we usually interact with OpenAI, right? So we do chat completions, and then the return model we want we want the client to use GPT 3.5, and then the response model is the user detail, and then this is the prompt, right? So the text I'm typing here is for role user, yeah, right? So if I execute this, what do we see? we can see that user is the result, right? So when we do user.name, we get Lambert, which is found here. User.age, we get 24, which is pretty much what's here, right? And that, does it make sense?
So this use case that I guess I see here is, if you're able to use Instructure, it kind of helps you have LLM in an application where you don't necessarily have to parse the JSON that's coming. You set up your data model the way that you want, and then it's much easier to use it that way for your downstream applications or something like that, right?
Exactly.
Okay.
Exactly. That's why some of those agent frameworks are using it too. By the way, right? So this is how it works, and let me see. In addition to that, there's a feature that I discovered this week as part of looking at the agents. Is this one here? So we can create a model, and then this time, instead of extending from base model, we can extend from OpenAI schema. There's a good reason for that. I'll show you. So let me evaluate this. And then in the schema, when we evaluate the schema of this user func, what do we see? We see some JSON, right? With the name being user func, description, right? And then the parameters, we see name and age, like this. And then we have some metadata, basically saying that name and age are required. So if everyone is familiar with Open API and JSON schema and Swagger, you can recognize this chunk of JSON over here. Right, so JSON schemas. So JSON schemas are basically a way to, let me see. It's a formal way to define the structure of data, right? And then since JSON is portable across many different languages and systems, it's a very good way to, using code, exchange data between systems, right, in a structured way. Okay, so that when a system receives this chunk of JSON, it will understand that there are two fields, and these two fields are required, and then it will also see what are the names of those fields, as well as the types. Okay, any question on that? Okay, so in here, I'm just grabbing the name fields of that chunk, which obviously returns user func, and we can use it to prompt ChatGPT again. Okay. So this structure here that you see, which is allowed by the instructor library, this is pretty much what's called function calling. So function calling, what is it exactly? When it comes to the GPT LLM, it's as if we are prompting ChatGPT, I mean the GPT LLM, and then we tell it that we require some inputs that follow this structure, right? This one here basically represents a function that we make available to the LLM, right? That function doesn't exist inside the LLM, but we just giving the LLM some text asking it to do something, and then based on what we tell it, it can decide to use one of the functions that we provided, right? Okay, so let me put it in simple terms. It's as if, imagine the LLM is a person, right? We tell it, hey, tomorrow we want to go run some errands, go to the grocery stores and stuff like that, right? And we have the ability to go get gas as well, right? And then we tell it and we give it and we tell that person an additional detail that the car is pretty much low on gas. And since the person knows that they have the ability to get gas, they can say, oh yes, tomorrow when I go to run the errands, I'm gonna get $50 worth of gas, right? I don't know if I'm explaining it well. Does it make sense?
Yes, it's clear. So basically, the LLM is the agent, right? And then you have different tasks, which is the grocery errand and then purchasing of gas. So once you prompt the LLM, once an input comes in, for example, someone will text from the LLM, can you do a grocery errand and also purchase gas at this location? Then the LLM already knows what tools to use, which is the grocery errand tool, and also it can invoke the gas purchasing tool.
Yeah.
Okay.
Pretty much. So basically, just to come back to this example here, we gave it a user function. That user function basically knows how to process name and age. That's what that function can do, right? And then we let the LLM know about the function by using the schema, which is basically that JSON chunk. And then in exchange, this is what we get in the answer from the LLM. So the LLM took care of the extraction of the name and age. And then it tells us that we can use this name and age to invoke the user func, which is our function here.
So the LLM is not calling the function? The LLM is just telling you how to call the function?
Yes, it's very important. It gives us the next action.
Okay.
And the inputs that go together with that action.
Okay, so why doesn't it call the function then? I guess.
Well, because it can't. That function exists on my machine. It doesn't exist in the OpenAI office or on the server.
Oh, okay.
So does it? Does it include the information retrieved from the function in its next prompt that it gives to the LLM?
Yeah. So the prompt is here.
Mm-hmm.
Hi, my name is Lambert, and I'm 24 years old.
Mm-hmm.
That's the prompt. And then, in addition to passing it that prompt, we tell it that, hey, by the way, we have a function that you might want to use to process the information retrieved from the prompt. And that function structure is this one, right? And then it will process it, and then it will say, oh yeah, I can actually find name and age in that prompt, and then use it to call that function. You know, it's basically like a small inversion of control, like temporarily. But basically, we let the LLM make up the decision that this function should be called. you know, because you can see that it's a choice. It doesn't have to. It's just available.
Okay. Can you go up? What does the function actually do? I think I may have missed that part.
The function, it just prints. It just
Okay.
prints. You see, using the name and age, which are defined here.
So all that the LLM is doing is to reading the prompt and then extracting the function and then the parameter, the inputs to the function, right? And then before that, we've already binded the tool, the functions to the LLM. So the LLM knows, you know, has the set of functions and knows which one to call to execute the task.
Yeah. So I can say it a different way. It's as if we ask the GPT model, hey, we have this guy here called Lambert, and he's 24 years old, and we can do something with this information, potentially using that function, you know? And then we ask it like, given the prompt, like, what would you do? And then it can decide to do something. Basically, internally, like the LLM could say like, hey, if it was me, given this prompt and this information, I will use that function to process it, to process the name and age. You know, it's as if we ask it for its opinion. Would you
Right. Yeah.
do it? But it's not actually doing it. It's in a way, it's advising us, hey, I will do it this way, given the preconditions that you provided.
So what would be a use case then? I'm trying to think of like a use case, like a
Well,
real life use.
it's coming. That's the
Oh,
final.
okay. All right.
Yeah, actually, I wasn't expecting to waste that much time with here. I wanted to go quickly, but
Okay. Yeah.
Ben, one, can you scroll up? So in this example, we have two functions, right? The tools and then tool choice.
no, we have one function. We have one function only. It's this one.
Okay. So
Yeah.
what's the tool choice doing?
Well, actually,
Oh,
like,
okay. I see what's going on. All right.
yeah. So the tool choice, basically, we
can list the functions, the different functions in it, right?
give it the name pretty much of that function. You know, because remember here when we did user func open AI schema name, what did we get? User func, right? So tools is the actual function, like this whole thing here.
Right. So let's imagine we have two functions, two tools. How is the tool choice, definition going to look like?
If we have tools.
Yeah.
Yeah, I actually ran into that same issue earlier this morning, and I mean, you will see in my demo, like I actually got rid of this one. This one is not actually required.
Okay.
This was just my scratch pad. I was just trying to figure out like different features, present in the library. And I think I saw an example where they structured it that way. I'm pretty sure there's a good reason for tool choice, but I don't know it. And since I didn't need it, at some point I just got rid of it. Because I was expecting this one be a list, but it's not. So
yeah, it sounds like if you have multiple functions, then
yeah.
So
this one may not be needed, but this one is for the purpose of the agents and stuff.
Okay.
Okay. So let's proceed. So we saw that this one returns the arguments as well as the name of the function, right? So that's what we get back. Once we get it back, we actually want to run that function. So how do we do it, right? So I saw some codes online, and then I thought about it, and then I made some tweaks and stuff, and then eventually I came up with this one. Like basically my main goal here was to make sure that the tool execution was fully typed. Okay, so I can explain. The first input is tool call. Tool call, you can see it in the response. It's this object here. Start completion, message, blah, 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 tool call, right? So if you remember the structure of this one, it's basically a map that has like a key of a key name function, and then it's a key to another map that has arguments and name, right? So given that, like the second argument is a list of those functions, you know. So we already saw what the function looks like, which is this one. Okay. So once we have the list of available functions, and then we have the answer from the LLM, we basically want to use the information provided by the LLM and then resolve the, then find the actual function in the list of available functions and then call it, right? So we basically we iterate over the list of functions to find the one for which the name attribute matches the name found in the tool call. So in our case, it's going to be user func. So in that list, there will be a user func that will match the user func coming from the tool. So once we have a match, we can extract the actual function implementation. So from that point on, the capital F, like func, is basically user func that we found over, where is it? So the capital func is basically user func over here. And since it's user func, I mean, we have a safety check to make sure that the function was actually found. If it's not found, then we return an error. But assuming that it was actually found, then this is just a print statement. Then what we want to do is to get the arguments, you know, like the name and age for Lambert, like Lambert, 24 years old. We retrieve it. It's a like by default, it's a string. It's a JSON string. So we want to turn that JSON string into something that Python understands. And the library we use here is Pydantic. And I forgot to share it with you. So Pydantic. It's the library I mentioned earlier that helps us have a better API for types in Python. Okay, so it has a helper method to turn that JSON string into an actual Python dictionary, you know, that will become the argument. And then we verify those arguments by doing the validation. And then we get this. And then this at this point becomes an instance of that user func. And then since the user func has a function, has a method called run, we just call it. And then we get the outputs, you know, and that's that. Okay. I know it's a bit complicated, but that's not the full thing I actually want to show you. So trust me that basically this helper function here, given the suggestion from the LLM, is able to actually invoke that function so that we can get the output from that. Okay. So, and then this is how I run it. And then you can see the logs that are printed here. So what do we see? We can see that it figured out that it's user func, and then it's gonna call it with name Lambert, age 24, right? And like I was saying, by default, this string is of type string in Python. And we want to turn it into a Python dictionary. So after we do that, where is it again? After we call that from JSON helper function, we actually get the arguments. And then you can see that the type has changed to Python dictionary. Okay. And then we instantiate that user func with that dictionary of arguments. And then once we run it, we get the string. User's name is Lambert and age is 24. And it's the exact function call here. So you can see that Lambert replaced that part here, and 24 replaced that part here. Okay. And I know it's a bit of a lot to like just look at a bunch of code like this in the presentation, but I'll share the repo so you can run it on your own machine and place breakpoints and all that, right? So essentially, this is what this helper method does. Okay. So let me shut this one down. I'm gonna open my other Scratchpad.
A quick question.
Go ahead. Yes.
So you have an agent here. How would you have another agent, like give it permission to call this agent's function that it has access to?
How will one agent give the permission to another?
Agent, yeah, to call this function? Or would you have to give permissions to each agent?
Well, I mean, those ones are not agents yet. They are just like some internal mechanism that we can assemble to make up an agent. Basically the concept of agents, like I will show you, it's one level above, because what we are all used to is basically call an LLM, get the response. And then with instructor, it's a slight improvement. We call the LLM and get a structured response. But it's not actually smart yet to be an agent. We need to add up some layers, and basically some of the bricks to construct that additional layer to make up an agent. That's what we are seeing at the moment. So there's a way to do it, yes, but it's not at that level of abstraction. It's a level above, which I will show you. So let's open the other Scratchpad. Okay, it's this one. Okay, so again, same thing, Marimo, like same imports, same key, like we saw this earlier. Setting up the clients, blah, blah, blah. And then we get into agents. Okay, so when we interact with the GPT models, what do we see? You can see, okay, so when you go to the UI, sometimes you want to tell the model how the model is supposed to behave. right? So you can say, hey, you're gonna assist me doing this, and that because you are my math teacher or something, right? So from that point on, when I ask you math questions, you should answer me that way and give me examples, right? So this way of like instructing the LLM before we actually prompt it, like these types of messages are called system messages, right? So using Pydantic, I try to give it some structure using some nicer structure, like in Python. You know, so our system messages, the actual prompts that we send to the LLM are called user messages, and then the responses from the LLM are called like assistant messages. There might be others, I don't know, but those are the ones that I'm using at the moment, right? So yeah, so system messages obviously will have for role system, and then content, like those are just some bogus examples just to see what it looks like. Okay. And then we have something interesting here. You notice that when you are on the UI for ChatGPT, you can exchange multiple messages, and ChatGPT will also answer you, right? So these exchanges are basically kept around in the context of a conversation, right? So what this context actually looks like is basically a list of uh, system messages mixed with user messages mixed with assistant messages. So that's what I'm trying to represent here using Python, right? And then since it's kind of since it's kind of like a lot to write, I can in a way name this whole block as like message list. You know, this is just a Pydantic feature, right? And then I'm just checking. I think this one might probably error. No, it works. Yeah, so message list. Okay, so this is not so important. So this is the same user func we saw, and then I added an additional one. This additional one, I call it default function. It doesn't really do much. It only gets a response as a string and then prints it. Okay. And then this is my first stab at building an agent, right? But again, this is gonna basically we are by just prompting, we were on the first floor, you know, the ground floor, right? And then this is just the first level for basic implementation. Okay. So, oh, actually, before so that you have a better understanding of what I'm doing here, let me switch back to the support material. Okay, so we saw all of these. We started looking at, we saw instructor, blah, blah, blah. You know, so we saw how we can retrieve data and so on and so on. We saw Marimo. So what's the A? So what's an agent? I have a book that I purchased like maybe 2-3 years ago. It's by Peter Novick and Stuart Russell. Peter Novick, I think he was director, or actually he might still be director of research or something like that at Google. He knows what he's talking about. He's been around, he's been in the AI field for like, I don't know, ages. This is how he defines agents pretty much. So an agent is anything that can be viewed as perceiving its environment through sensors and sensor acting upon that environment through actuators. So what does it mean? From the definition here, you can picture an agent as operating into an environment, right? And maybe it has some sensors that can detect noise, right? So the agent will be able, through its sensors, to like hear the noise, so that's how it's perceiving the noise in the environment. And then based on the nature of that noise, if it's very loud or it's a broken window or something, it can decide to act, right? So maybe it decides to ring the alarm because the noise happened at 3 in the morning when everybody is supposed to be asleep, so ring the alarm and then maybe call 911. That's an example, right? But when we go through the book, this part related to perceiving, actually I can show you. I think I have the book opened here. Let's see. So I just copied that definition from here. So I don't know if you can see it. Yeah, so when it comes to perceiving, he has this term called percept. It's basically the information or the input being perceived by the sensor, right? And this one is pretty much a list which starts by being empty at first, right? So if you remember what I was showing you earlier, we have a list of the context of the conversation. It's a list of system messages, user messages, assistant messages, and so on and so on. So in that sense, with regard to the definition, this is the list of percept. I think I tried to name it almost the same, right? So the list is empty by default, like in the definition. And then once it's the agent wakes up, it's preceded with the system messages so that the agent understands what it's supposed to do, what is its role. And then when we prompt it, we are basically appending to that list. Just like when we chat with ChatGPT on the website. Okay. And so I can skip some part. I'll show you some other important things. Yeah. So when you actually read the book, it has this notion of a rational agent. I highlighted the key parts here. A rational agent is an agent that basically that tries to do the right thing. And if you think about it, it makes sense because we want to build agents to be useful to us, right? So the agent should not have another agenda of not being useful, because otherwise what's the point, right? So agents that want to do the right thing are rational agents. So there's this concept here. And yeah, so when we combine the idea of the percepts, like the information being captured by the sensors, and the fact that the agent wants to do the right thing, we can maximize the performance of that agent, meaning that the quality of the result is going to be increased, by just keeping the percepts around and having and implementing the agents to be rational. And yeah, so I won't bore you with too many details here, I think. Yeah, so it has this definition also at the end. So the job of AI is to design an agent program that implements the agent function, the map that implements the agent function. That agent function is basically the mapping from percepts to action. So if you remember the function calling example we saw earlier with the instructor library, we gave it some percepts. Basically, we gave it some prompts, and then it returned us an action. So it didn't invoke the action. It gave us the name of the function to call together with its arguments, right? So it follows exactly this part here. So we assume this program will run on some sort of computing device with physical sensors and actuators. So in our case, it's just software. So it's text in, text out, or data structures out. And then this is what the agentic architecture is. So it's very simple, the definition here. So agent equals some architecture plus program, blah, 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 blah. And then he has it in like a pseudocode format. So we're accepting the percepts. It gets appended to the list of percepts, appended here. We look up the action to take. If you remember the list of functions we were passing to ChatGPT to GPT-4, right? It will look it up and then decide which action should be taken. So that means it will return, like in the example earlier, it will return the user func together with name Lambert and age 24. And that's it. It returns the action and that's it. That's pretty much what the agent is. So based on that definition, I took a first stab at an implementation. So you can recognize the percepts here. This is just, this is not part of the definition, but we need it, so we know we're gonna use GPT-4. We need a client for OpenAI. And then we have a list of toolbox. That list of toolbox is pretty much the table here from which the functions are going to be looked up. Okay. This one we don't need. Okay. So let me skip over here. So let's say the agent is has been implemented and we started. Then what? What's happening? It's gonna receive one of those messages, right? So most likely it's gonna be the user message, and then we append it to. For instance, we append it to the list of percepts, which is empty by default. Okay. Once we append it, we collect. We basically collect the context information. This one is not part of the definition, but I did it because it's needed. So what I call context here is us providing system messages to tell the agent what's its role. And then we combine that with the percepts, meaning the list of prompts that we have been getting and appending to the list of percepts. I take the whole thing, so that makes up the whole exchange between, if you want, us and ChatGPT, or between the agents and the LLM. We take the whole context in messages, and then we pass it along, right? And so this one will be GPT-4. This is the whole context of messages, including the very last one, which is passed. We give it the toolbox, and then it's gonna run. When it runs, eventually it's going to answer. And usually LLMs don't just have one answer. It's just that we usually pick the the first one, which is usually the best rated one. So I don't bother with the extra choices. I just pick the first one because it's the best according to the LLM. And then what do I do here? I do that same logic to execute the function. The tool call is basically name user func. Name Lambert, age 24, and then the function name is user func. That's what it is here. And it usually comes back as a list. That's why I have to iterate through it. And then we have this function here called actuate. What's actuate? So actuate, the actuate part is not part of the formal definition because this one only returns an action. So that action here is basically what tool calls is, right? So at that point, the agent is done doing its work. We take that suggested action, and then we have to run it with the actuate. So the actuate function is nothing but the one I was showing you earlier that maps that finds the name of the function that was suggested to be used. It matches it with what's available in the toolbox, and then make sure to run it. Okay, does it make sense? Okay.
Yes.
Okay, so that's pretty much for the scratch part. Now, let me make more sense with all of this. Actually, let me invoke it real quick so you can see. So here I have some example. I pass it some system messages, like you will collect the personal details of any mention. Oh, I have a typo here. Of any person mentioned. Otherwise, just answer the question, right? And then the toolbox has this default func that does nothing but just to print a string. And then this one prints the user details, right? So if I run this, I should get something. Maybe. Did I skip something here? Oh, okay. This one, okay. I'm just instantiating the agent here. So the agent is called person details agent. Okay, so once we have this, then I actually prompt it. Hi, my name is Lambert, and I'm 24 years old. And Rigobertine is 22 years old. So there are two people in there, right? And then show it found them both. So we see Lambert, 24 years old, and then we actually run it. And then we have Rigobertine, 22 years old, just like in the prompt, and we run it, right? So we can see that it triggered again the user func like we saw earlier. But then what if I ask it something odd? What if I ask it how to convert the temperature from Fahrenheit to Celsius? Okay, can anyone guess what's gonna happen?
It's gonna return the message.
It's gonna return a message, right?
Yeah, because you can convert anything.
Yes. So you can see that in this case, it made a different choice. It simply returned us the answer. It didn't use any tool in that case.
It's non-deterministic.
Yeah, because based on the prompt, it did some thinking on its side and then determined that, oh, we can use any of those functions, so let me just answer it. So that's what happened here. Okay. So let me switch to the actual demo. So sorry about that, guys, because I didn't think it was that much, but I ended up writing a bunch of stuff. So, can everyone see my screen, my ID?
Yeah. I have a question, but I'll wait until you're done with this then.
Okay.
More of a comment / question, but continue.
Okay. So we saw the definition, right? We learned about percepts, table of actions. It's just the toolbox. The percepts are a combination of these three types of messages. Toolbox is nothing but the functions like these two. The actuator, right? The definition talks about returning an action. So here I combine the two concepts. The action is back, and then we actually run it by calling the actuate. Okay. So you saw that we went at the first level, right? In our construction of the agent. The agent, like I just showed you, this one, it's kind of usable, but it's not that different than just prompting, right? Because we ask for something and then we get the straight answer, right? Thinking about it that way, the agent is too predictable. Basically, someone could have just coded the logic directly without involving an LLM, right? So to make it more independent, we have to structure it a different way. So if you remember that Codium example in which there were steps, for additional looping and stuff like that. Well, I mean, I didn't come up with this one 100%. I came up with this one after reading a bunch of stuff, watching videos, and then I got this idea from that. It's not, I didn't invent it pretty much. So basically, I'll try to explain what I'm trying to say. We saw this concept, right? Reason and then act. We saw this self-refine, and then we saw the flow engineering as part of the alpha codium thing, right? So these concepts with the formal definition as per Peter Norvig in the artificial intelligence book, plus like inspiration from what I read and so, there's this flow that I try to implement. The one I implemented is not that complex. It's only it's probably like 2 levels, 2 additional flows. So thinking, and then deriving the inputs, and then picking a tool from the toolbox to run it. This is pretty much what React is, that first concept. Okay. I'm not really, you can see that there's no step where the arrow lead to itself. Basically, I've seen some examples on how to do that, especially if you look at this GitHub repo. They have some nice examples on how to do that, but due to time constraints, I haven't done it, right? So I'm not using that concept here. And then, let me see. The last concept was flow engineering. So flow engineering, I created a workflow pretty much, okay? So you can see that it's doing some thinking, deriving inputs, picking a tool from the toolbox. It does some processing, and then it inspects the results, the initial results from that toolbox to decide what to do next. And what to do next means potentially picking another tool from the toolbox again, and then doing further processing. And then inspecting those results at that stage again, and based on the inspection, potentially picking yet another tool from the toolbox to obtain some final results and then send it to the user. So I try to implement that. Does this graph make sense?
Yeah, because it uses percepts as its input, so it's whatever it's perceiving at any given moment, right? So
yeah. Okay. So the scenario I actually picked it like, I think it was maybe 7 a.m. this morning. I was in a hurry. I was like, okay, what can I come up with that's like a bit straightforward? So the scenario that I picked is, let's imagine it's Saturday, right? So Saturday night, there is a club called the Ubuntu TechHive. It's a high-end club. And then the agent is the bouncer, right? And that bouncer basically filters out, people who are not supposed to enter the club, or lets the people who are supposed to get in. And to help that bouncer in as part of his work, like he will rely on the host, on the hostess that will lead the VIP guests to the tables in the club. And it will also rely on the security agent on site to check the IDs, right? Make sure that people are at least 21 years old, right? And then the bouncer can, in addition to that, make sure that they have money, right? Because clubs want to make some money, right? People have to buy drinks, they have to pay for the cover, so they cannot just come empty-handed. And also, it's possible that the VIP guests may have some people that they would like to celebrate with, right? So since they have a table, they can let the club know about a guest list. And if people are on the guest list, they can just get in, So let me show you how I try to implement this. It's not working perfect, but it's just to convey the idea. So I have this file here. Let me zoom in. I don't know if I can zoom in on this one. Wait, hold on. Let me switch to. Let me use this one. Okay, so it's this one. Okay, is it visible? Is it visible?
Yeah.
Yes, it is.
Yeah. Okay. So what do we see here? We have we instantiate the client and all that using instructor. It's hidden away into these helper files, and then this is to bring the more focus to the file. So first we have the security person on site. So the security agent for Club Ubuntu TechHive. It helps the bouncer manage the line and check the guest list following the club's rule. If the person is at least 21 years old and has at least $20 in cash, they can enter the club. If the person is on the guest list, they can enter the club. If the person is a VIP, they must have at least $1,000 in cash to get a table. Okay, and it's very simple. Basically, this security agent is only. Yeah, Kofi, you have a question? Go ahead.
Yeah. So, how important is the comments up there?
Well,
as far as the.
If I'm not mistaken, I think the instructor library makes use of it, to provide additional metadata to the LLM.
Yes, it does, but I wanted us to point that out. It's very important.
Yeah.
Yeah.
Yeah. So basically, this security agent, I mean, okay. So I'm using agent here loosely, right? It's not agent in the sense of what we have been studying today. It's an agent like a security agent, an actual one, right? So let's say like security person, okay? Because this one is a function like we saw the user func. Okay, so this club security function is only looking for the person name, age, cash, and then a flag to figure out if they are on the guest list or not. And then if they are, I mean, once this information is collected, it returns that information, you know, as a person object, right? So it populates that person object and returns it. Okay, and then the host or the hostess collects the cover, charge, and assigns tickets to guests. She checks the guest list, assigns guests to VIP line, blah blah blah, manages the VIP and table service. You know, check for the $1,000 at least. You know, if the person has money for a ticket, let them buy it and mark them as having a ticket. You know, wristband, blah blah blah. Let me see. Yeah, so basically, from the description here, this metadata, what we are really interested in is, in addition to the person details, we are also looking for whether or not the person has a ticket, you know, at the end of that step, and if the person is on the guest list and if the person is a VIP. And then once this information is collected, we return the guest object. And then here comes the bounce. Yes, go ahead.
Why are we, can you go back up, please?
Sure.
Yep. So why are we, the club host, why is he requiring the name, age, and all that while we already retrieved that from the security agent?
Well, I mean, I've seen on TV like people who pay a lot of money to be in VIPs. They like to have the DJ call the names.
Yeah, okay, good example.
Okay.
Atalaku, quoi.
It's as simple as that.
Vele, atalaku.
Yeah. Okay, so here comes the bouncer. So the bouncer is the actual agent. You know, you can see some of the. Oh, actually, let's look at what the bouncer does. Welcome to Club Ubuntu TechHive. I'm the club bouncer. I'll be managing the line tonight for the club. Oh man, I see I was tired. I have tonight twice. Anyway, I will be deciding who can enter the club. My decisions are based on the following criteria. The person must be at least 21 years old. The person must have at least $20 cash. The person must have a ticket or be on the guest list. There will be $20 cover, blah, 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 VIP tables. Tables are limited and so on and so on, right? So one additional thing that I've added these two properties here. The club capacity, only 100 people, and there's only 10 tables, okay? And then the toolbox, the security function and the host function. And then that's it. This whole thing here is the agent. You know, I'll show you later the implementation of this guy. Right. So once we have this, we can run it. And then this club bouncer class has a function called manage line. This is the function that accepts the percepts. You know, so you can see the percepts here are user messages. You know, so John Doe 25, $50 on the guest, and they are on the guest list. Lambert 21 only has $20 cash, and they want to purchase a ticket. You know, and then I'll run it for you later on. So let's look at quickly the implementation of Club Bouncer. But first, let's look at agent. That agent is the same one that I showed you in the notebook. I just cleaned it up a little bit, right? So you can look at the implementation yourself. And then the Club Bouncer implementation, we saw in the other file person, so this is the Pydantic representation for it. We have also guest, and notice how guest inherits from person. So it means that guest will also have the name, age, cash, and the guest list flag, right? And in addition to those, it's gonna have a ticket or not. I think I repeated myself here, but it doesn't change the outcome. And then the last flag is whether it's a VIP. This one is not needed. I forgot to delete it, so you can ignore this. So the actual Club Bouncer, now the agent itself was the first floor, right above the ground floor. Now we are on the second floor. That's where we found the bouncers. So you can see that we lifted from the direct prompting to having a base abstraction through the agent class. And now we are at the level where we can deal with the domain in which we operate. In this case, it's the club and the bouncer, right? So this implementation now is free of any technical details about the agent, okay? So what it does have is the capacity and the table count, okay? And it also has two helper functions. One helper function to check the person, the other one to check the guest details. So what do we see here? We have some logic to basically inspect what the LLM returned to us, okay? So the LLM will take care of passing that text, like the system message for the role of the agent, as well as the individual guest details and all that. All that we know is that once those steps are done in the low level, we end up with a person first. And then we check the details of that person. Is the person 20 or at least 21 and has at least $20? Yes. So let's take a closer look. Do they have at least $1,000 in their other pockets? If yes, then this person is a VIP and they might want a table. They might want a table or something like that. If not, I forgot what this case here. Yeah, so if they have at least $1,000 and the tables are, and there are no more tables, then they have to wait. If the person is on the guest list, then they can, we mentioned that. So basically what we are doing here after after inspecting the person details is that we are constructing some additional prompts. So those additional prompts are here. The initial guest details and system messages are coming through. We get the first set of results. So we're on that stage here. On that stage, we inspect the person details, which is this one. Okay. And then if they match the club requirements to be able to party in the club, we end up with a guest, and then we just inspect the guest. And if the guest is some guest list, oh, I was sleepy. This one is supposed to be down here. Let me see. So I think this one is supposed to be here. Yeah, so basically once every time a guest gets into the club, we have to decrease the capacity. So we do -1. Same thing for VIP, we do -1, but in addition to that, we have to decrease the capacity of the available tables. And then if there's no match, blah, 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 we just default to sorry, you can't get in. Okay. Same thing for the person. If it doesn't match what we expect, we default to sorry, you can you can enter the club, right? And then this is that function to manage the line. So this is the percept. Okay. The percept comes in the form of a user message. So this one will be the details of the individual people waiting in the line. Okay. So what do? We go ahead and do call process. So process is in this one. So that's the same. I'll just rename the function run that we saw earlier for the agent. It does the same thing. Okay. So the first thing it does is to process that initial percept, and then we get an outcome, but we don't know what the outcome is, right? So since we don't know what the outcome is, we have to check. Is it a person? If yes, check the person using that function we saw earlier. Is it a guest? If yes, check the guest using the other helper function we saw earlier. And then if for some reason, since we're keeping track of the context, you will see it when you run the code. We might end up with a list of outcomes also. And if we have a list of outcomes, then we need to do that same work, but for each item in the list of outcomes. So that's what I have here. And then the last check is that if for some reason we enter some prompt that has nothing to do with guests wanting to get into the club, maybe like somebody standing outside asks goes ahead and asks the bouncer, hey, you have some light, it's cold outside or something, the bouncer can just enter it, so that's the case for string. This one, that's the case for string. Otherwise, and then in the case for string, we just print it. Otherwise, we just say, sorry, you can't enter the club. Okay, so let me try to run it. Like I said, it's not perfect because I did it in a hurry this morning, but it's just to give you an idea. So I can run this. Okay. So it printed some stuff. So let's see what it is. Okay, so you can see how, actually, let me show you the prompt. So I sent an initial person, John Doe, to the bouncer. And then after that, I sent Lambert. So you can see that it was able to parse the person, and figure out the details. Like John Doe has 25, he's 25 and has $50, and he's on the guest list, right? So we can see it from here. So it means that, again, it's the same John Doe is on the guest list. It doesn't have a ticket. It's not VIP, right? And then what does it say? Welcome to the club, John Doe. And then what about Lambert? Same type of processing, 25, $50. Oh, what am I seeing? John Doe. Oh, you know what? I think I have a bug. Yeah. Anyway, I have a bug somewhere because this is supposed to be Lambert twice. But anyway, it does the processing from first level and then pass it to the second level. So that's the first level, pick another tool, and then that's the second level. The first level tool being the checking for IDs and money. And then the second level tool being the one checking for VIP and stuff like that. So we have like these two. And then the yellow part is that for each one of those stages, we think. So after obtaining the person details, we think how by sending the information to additional information to the LLM. And then from the answer, we pick the next tool, which is to figure out the guest. And then instead of thinking again, we just print. We just proceed with the final result. And that's what you see here. So in this case, I think it's because of my bug somewhere. It says you can get into the club. And that's it for the demo. Now questions, if you have any.
I have comments, but I'll let if anybody else has a question.
Sure.
That was pretty good, by the way. And then I just wanted to mention that the tools that we were asking questions about, it looks like we can actually provide different kind of, like let's say we use Llama and then ChatGPT and Cloud, we can like provide those inside the tool, and the preferred option will be whichever one we want to go with first.
Definitely. But basically, what I was trying to convey with today's presentation, right? You can see how I've structured mine. You know, it's not a full implementation. It's not something production ready. You know, it doesn't take into account the number of tokens used and blah, 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 right? But the main idea is some of those framework authors probably went through some similar steps, and then they structured the framework in the way that they think about it. You know, so coming back to my point, the point I was making earlier, this thing is so new that I don't see a point of being constrained to, you know, one author framework, like way of thinking, you know, and being limited. You know, we can think deeper about the problem we are trying to solve and then come up with something that makes sense. You know, we saw the definition of an agent from an expert working at Google, directing a bunch of smart people. You know, his definition of agent is pretty open. It has some specific things that it requires, but besides that, it's pretty open. So it means that nobody has the monopoly of the best implementation out there, you know. So okay.
I can't help. Okay, maybe I'm thinking about it in a naive way, but I can't help but think that I'm being a little bit philosophical here. I can't help but think that us as humans, we seem to be someone else's ChatGPT. And let me explain. So when you what'd you say?
So the LLMs are prompting us? Is that what you
No,
try?
no, I'm saying like someone has to be prompting us. Let me explain what I mean. So the percepts, right? The percepts, like you say, it's constructed via a list of if you go back to system messages, assistant, and things like that, right?
Oh yeah.
Right. So that you need the precepts to get going, to start with, you know, building an agent, right? Otherwise, you know, you're not going anywhere. So us, when we're born, we don't have any notion of anything, right? You know, I'm taking a stab. I'm guessing we don't have any notion of anything. We don't know really anything. We're babies, but then as we get older, we learn. We're getting those contexts, those percepts we get that, and that helps us make judgments and make decisions throughout our lives, right? And they get stuck in our minds almost our entire life. Am I correct? So it seems like, you know,
Well,
it-
I see what you're saying, but I'm thinking from what you just said, I'm thinking about that part, the system message. I mean, that's my belief. It's not scientific or anything, but I'm pretty sure that some basic level of software is being downloaded into our brains before we go to production.
so that's what I'm saying. So
You
who's
know,
making that download?
I think instincts. Like, if you have some things, like I think that's where it comes from. Some system messages.
Yeah, that's exactly my point. So it seems like we it seems that we are someone else's, chat GPT, right? So like there's like like you said, there's like messages being downloaded in us before we go to production. So where are those percepts coming from, right? So anyways, I'm maybe going on a tangent here, but I thought it was pretty interesting to, as you were going through this, to kind of mimic and look at it in as us as humans, and how we also make decision, and how we also um you know basically do it in an algorithmic way, right? So but
Right.
yeah, it was really interesting. At the end of the day, it looks like all of this is again code, right? Like you code the decision tree, um, the algorithm, basically you code it, right? And then there's a little bit of level of autonomy from the AI side of things, but it seems like it's not a whole lot, right? Am I understanding that correctly?
Yeah, I mean, for the code itself, I mean, when you say not a whole lot, I would say like it depends. What
Mhm,
I've done here, I think it's just a trivial like implementation, and it may not even be like correct 100%.
mhm,
That's I coded it based on my current level of understanding. But if
mhm,
when you start looking at the implementations of like some of those frameworks or what some other people are doing, you can see that there's a whole bunch of other stuff they take into account. For example, the tools, right? The
mhm,
tools that I showed here are very trivial, but I think if you look at uh, libraries like LangChain, they have some tools for some pretty complicated stuff, you know,
mhm, mhm,
are part of the implementation, tools that know how to go, I don't know, run Google searches, tools that know how to, I don't know, process audio.
mhm,
Like there's a whole bunch of stuff, you know, but as far as the core logic itself, I don't think it's that complicated, especially if we want to follow the definition from that book, right? You
mhm.
know, but for an actual project, yeah, I think it depends. It
Yeah,
depends depending on the project. If it's something complicated, then the implementation might be complicated. If it's something trivial, the implementation might be trivial. Like, yeah.
yeah.
So,
But yeah, otherwise, yeah, it's very helpful. It's very good.
yeah.
Yes, Baruch, the recording we'll get it sorted out, and then when we post it, we'll share the link in the Discord.
Mhm. Yep, yep. Any other questions, thoughts? You
No,
can.
thanks a lot. That was pretty detailed, and thank you for going through not only explaining the codes and also doing the test, but also talking about your book, the book that you read too, because I'm about to download it as well. So thanks a lot.
Yeah, yeah, no problem. No problem.
Yep.
Yeah.
Actually, do you think that what has helped you the most understanding this agent? Like, was it mostly I guess, let me rephrase the questions. Was reading those scientific papers, was they helpful in for you to understand
Well,
not the book, the scientific papers, to understand agents?
Well, I mean, they were pretty boring for one, but I mean, I would say yes, they are helpful.
Okay.
They are helpful in the sense that, like, some people took the time, like maybe months or years, to research some things, and then we, in a way, it's a shortcut to like come up with good ideas.
Mhm.
Because otherwise, we just code in the dark. We don't even know what we're doing.
Mhm.
But the fact that they did some research and they actually collected some numbers, and then you know they did some science pretty much,
Mhm.
to back up their findings. So it's useful in that sense. That in that sense that if you read one of those papers and it gives you a good idea, that good idea, you can be sure that if you start coding it, you can sort of like expect a similar outcome as what they came up with,
Mhm.
you know, versus just inventing something random, you know. So, because the space is so wide to like come up with solutions, so those papers are helpful as a guide.
Right.
So,
Okay.
mhm.
Thank you as usual. I definitely see a lot of business use cases where you can use that. So thank you for sharing that. And then
Yeah, I think next time you're presenting the more advanced version of this, right?
actually, when you were presenting, I saw how I could not this version, but like the other version, how I can integrate that, because that
Yep.
can definitely do a lot of business stuff. I was thinking about something basic like for a business, use case, just managing inventory, because it costs a lot of money for companies to do that. But the way you explain, I have the impression that you can just build one that's going to replace the person who's taking care of the inventory system, because it's very repetitive.
Okay.
Did you just fire somebody on the
Yes,
spotlight?
definitely. We're trying to save money, so
Yeah. No questions in the chat. I don't see anything.
May I have a basic question because I'm new to coding? How would you define what a class is? Because I still struggle with the concept, and I see that we use the class a lot, in it,
It's a
things.
blueprint of whatever you want to build.
I'm sorry, what did you say?
It's a blueprint of whatever you want to build. For example, if you're looking to build like a TV, right? There is a blueprint for building a TV. So once you have the blueprint, you can now build like multiple TVs with it. So that's one basic way to look at it. Now, to go into the details, let's say you want to build a user. Then you can just define that in any user that you're building, you want to provide a username, an email, and a password, right? And then now you can create multiple users with that. And then you can have like a user called Mark, John, Jeff, and all that. And then you can also use children, which will, be implementing the parent. And then now you can add like their shirts, the jersey colors, and all that. So it's just a blueprint. Does that make sense?
Yes. Thank you.
Mhm.
Thanks God I didn't ask Benjamin. I'm glad. We will be arguing.
I know, that's why I kept quiet. Let me skip this one.
I think that's what I'm going to do now. If I have questions, I will wait at the end of the session. I will ask my questions. Benjamin is not going to be the one to teach me.
Benjamin is too advanced.
Yes, it doesn't break it down to my level and we argue. He thinks that I'm doing that on purpose, but it's not the case.
Trust me, I did a lot of I did a little bit of programming, but Benjamin sometimes talks about topics. I'm like, I feel like I'm elementary school or something.
I'm glad to hear that. I'm glad to hear that. I'm not the only one. I'm not the problem.
That's the bed. Yeah. Any other
comments? Anything?
No, the only comment I have is that it definitely is an interesting topic. I learned a lot, and yeah, thanks for taking the time to go through this and explaining this to us and doing the research especially, because I think that took a lot of time.
Yeah, and also like, don't just limit yourself to what I said. I might be wrong. Like I have a step last night, like I don't know what I'm talking about. So, hopefully some of the links that are included in the support, plus the code, that's like use it as your starting point and then go figure it out. But don't listen to me. I don't know.
Yeah. So it looks like we have presenters for July next month. Actually, yeah. We need presenters for August, right? So I think we can start soliciting that now.
Yeah. Anyone interested? Like,
I definitely want to put my name down for August. The topic, I was still think about it. I was thinking about actually Docker and how to pretty much like build and all that stuff. But I believe Samda told me last week that somebody is handling that. So I will still need to figure out what to present.
Yeah, I have a topic for you. Don't worry about it.
Oh my God! Not from you. Not from you.
and also, right? Like even if the topics, I mean, the topics are all those topics have so many